Hello and welcome. I'm John Fisher, a principal automotive business developer at AWS. Today, as part of our analytics track, we have the great pleasure to give you a customer example regarding how AWS can support data-driven development across the value chain, in this case with Volkswagen Commercial Vehicles. From Volkswagen, we're fortunate to have with us Dr. Michael Nolting, Director of Digital Services and Data Analytics, and Dr. Mohammed Al-Rifai, a lead data scientist, and they will help us to dive deep into this topic. And I'll be turning the presentation over to them shortly. First, I'd like to set the scene by reminding all of us that the automotive industry is facing an unprecedented set of challenges, both at present and on the horizon. Today, customers of all classes of vehicles now hold up their smartphone as the standard for both connectivity and usability, and thus they expect the same features from the automotive industry, including real updates, apps, as well as smart services. At the same time, increasing amounts of traffic on the road, especially in urban areas, is leading to frustration for drivers and changing the way people interact with the world. As we've all seen, shopping, even for vehicles, is increasingly moving online, and dealer visits are becoming less frequent. New mobility services are continuing to emerge and have become viable alternatives to vehicle ownership. This is why we expect to see more changes in the automotive industry in the next 5 years than we've seen perhaps in the last 50. And we will all have to change our ways of working to respond to this new environment. A quick word about the customers that we have in the automotive space. The list shown here is just a sample, and at AWS, we work with a broad set of customers across every piece of the automotive value chain, from vehicle OEMs and tiered suppliers, all the way down to tech-specific players, as well as new mobility startups. One of the reasons AWS is working with so many automotive customers is that we enable a data-driven value chain. Today, most automotive customers are split up into organizational silos. They have separate organizations for business functions like R&D, product development, manufacturing, sales and marketing, connected vehicle, and new mobility. And unsurprisingly, in most cases, this organizational structure is also reflected in the way that these organizations handle data. The data is also in silos. AWS can help automotive customers to break down these silos and create enterprise-wide data lakes. With the broadest and deepest set of features for data warehousing, analytics, and machine learning, we help automotive customers to get the most out of their data and realize improvements across the value chain. With that, I'd like to turn it over to Michael Nolting, who's going to take us through today's example.
We want to tell you today our story, how we are currently improving our products by leveraging all the data we have from our car fleets. This includes data from our test fleets and pilot customers. Data has helped us to improve our customer understanding dramatically. But we had to learn to process all this data. We have tera to petabytes of them. In our example use cases, we show you today how we use data to design the perfect car for our customers. For example, in terms of fitting the car components to their usage profile, and how we use data to predict potential damages of components of a car to prevent workshop visits, since uptime is key for our B2B customers. Yes, you heard it right. We have B2B customers. We are the brand focusing on business customers. For this, we deliver and produce cars helping business customers to earn money. This can be craftsmen who use their car to transport material to their clients, as well as the German Post that delivers packages. Our target group is also abbreviated by CEP, which stands for Couriers, Express, and Packages. This customer group is very, very diverse. This is why customer understanding is so important for us. Some deliver goods, others want to deliver themselves to a great place for vacation. Some clients are craftsmen and need to deliver bulky goods like a ladder. Others have to go as fast as possible to broken down vehicles to assist the drivers. So the customer needs are really very different, and we have to serve this long tail. And data helps us to understand them. John already mentioned this in the introduction, that the automotive industry is changing dramatically. As a result, the automotive value chain is changing too, and this helps us. Whereas in the past, car manufacturers only produced cars and sold them, they are transforming into a software company now, since we have to offer digital services and get data to do data analytics. And we have to do data analytics, since if we do not do it, we are less customer-centric then our competitors and our market share and profits are at risk. Data can help us to find cost savings and to survive this transformation. And now I'm handing over to Mohammed, who will explain you our example use cases.
Thank you, Michael. So the rest of this presentation, I will be showing you how we use the data to build the best vehicles for our customers and deliver the best services for them. Let me start with two concrete example use cases. The first use case is about vehicle design optimization. So we want to build the best vehicles for our customers. And in order to do that, we test our vehicles very extensively before we start selling them. So when we build a new vehicle, we do a lot of tests trying to measure the load on different components in different driving situations. We collect a lot of data from our test fleet. We analyze this data and we make sure that the vehicles will be working as expected in every possible driving situation. However, in order to make sure that this is the case, we also collect data from pilot customers. So we have some pilot customers where we get their consent to install some data loggers in their vehicles and collect a lot of data while they are using it. And then we try to compare this data with the data from our test fleet to make sure that, first of all, we are testing the vehicles in a right way. On the other hand, to understand better how the customers are using our vehicles. By doing so, we are able to achieve two things. On one hand, we're able to build the vehicles that fit the customer needs. On the other hand, we can also optimize our testing procedures to get it closer and closer to the real-world usage. The second use case is about 100 uptime for a customer's fleet. As Michael mentioned before, many of our customers are B2B. They are business customers. Their business depends heavily on the usage of our vehicles. For example, post or taxi. So they want to have the vehicles up and running all the time when they need them. In order to make sure that this will be the case, we have to reduce the downtime of the vehicles as much as possible. And to do so, we collect a lot of data from the vehicles. We monitor the health of each component in the vehicle over the time. And we try to come up with kind of a prediction of when a component might fail in order to alarm our customers in advance so that they get enough time to react. So this, for example, if we collect data from different components of the vehicles, a lot of signals from the vehicles, we measure the load on the different components over the time. We then set some thresholds and we try to make sure that we will know in advance before a component would fail so that we can notify our customers and help them avoid this downtime. These are two examples. In order to realize these two use cases and more other use cases, we need to have scalable vehicle data analytics solution because we are dealing with a lot of data that come from the vehicles. Our vehicles, they are equipped with a lot of sensors that collect a lot of data. And in order to analyze this data, in order to be able to realize these use cases, you need a scalable infrastructure. And that's what our project SNOWPARK is all about. And in the rest of this presentation, I will give you a bit more details on how we implemented this and how we realized this project using AWS services. Before I start with that, I want to highlight the challenges that we are facing here. So on one hand, we have vast amount of data. We have data from thousands of vehicles from our own test fleet, but also from our pilot customers. We are collecting hundreds of terabytes of data, and these data come from tens of millions of driving kilometers. It's really a huge amount of data that we are dealing with. On the other hand, data is heterogeneous. Not all of the data is structured. There is a lot of unstructured data as well, like text, for example. And we need to have a scalable solution. So of course, we would go for a cloud solution. But on the other hand, this data alone that comes from the vehicle is not enough. We need to join this data with other data sources from our legacy systems which are on premises. So we cannot bring all these legacy systems to the cloud for different reasons, for security reasons, but also for data privacy reasons, but also because maybe we're not ready yet to do it. So we plan to move to the cloud as much as we can, but we are not ready to move everything at the moment to the cloud. So this is a challenge. So how can we solve this issue then? You need the cloud infrastructure. On the other hand, you need all this data that comes from legacy systems. So this is a challenge that we had in the project, and that's why I'm moving now to the next slide. I'm showing you now our idea how we fix this at a very high level. So in principle, we have two parts. So the first part, which is on premises, where we have the data that comes from the vehicles, but also where we have our legacy systems and data warehouse. On the other hand, we have this solution on the AWS cloud, where we can process the data in a very scalable and efficient way. So the way we did it is that we decided to upload the data, the raw data, to AWS, store it there, process it there, extract the insights and useful features from the raw data, and then download these results into our on-premises systems, join it with our legacy systems or data sources that are on premises, and put them all in data warehouse, provided to our engineers, where they can then use AI tools to analyze and process. This is how we did it, and I think this is kind of a solution that is very realistic for many of the companies. We know that a lot of companies moving to the cloud, but they are also facing similar issues as we did, and that's why I think sharing this information with you might be very helpful for you. Now, to give you a closer look into our solution, you see here that we have been using a lot of different components, different services from AWS. The goal was always to have scalable, but also serverless architecture. Why do we do this? We do this because we wanted to make sure that we also reduce not just the time and the cost for processing the data, but also reduce the complexity of building the system. Because this is a system that's evolving over the time. We have more and more requirements from business, from our engineers that we have to realize, and we wanted to be able to do this as fast as possible. That's why one of our goals or targets was to try to use serverless services as much as possible. In the next slides, I will be giving more details about the different components step by step. So I will start with the first part on how we import the data to AWS, and then how we process the data to extract useful information out of it, and finally, how we download this data into our network and join it with our own databases. So data import. First of all, we are dealing with terabytes of data. There is a lot of historical data that has been already collected the past years from our test fleets and pilot customers, which we needed to import to the new infrastructure on AWS. We use S3 buckets to store the data, and the challenge at the beginning was that we are dealing with more than 100 terabytes of data that needs to be imported or uploaded. And how we solved it is by using AWS snowballs. We found it very convenient, very easy to use. Within a few days, you have the data already copied and imported into S3 buckets. After we did this, we had to find a solution for how we upload and import new coming data, because we continue collecting a lot of data. The data is growing. We have about 50 gigabytes data per day, new generated data, that needs to be uploaded to this platform. In order to do so, we have developed our own desktop tool that will be used by our engineers to upload the data to AWS. This tool is built based on AWS software developer kits. Very easy way. You have all the things that you know from AWS. You have the authentication, two-factor authentications. It's using AWS SDK. It makes it more easy and convenient to interact with the S3 bucket. This tool is being used now for different modes. It can be used for uploading data on demand, but also used to automatically upload new arriving data by monitoring some folder on your network. Whenever data arrives to that folder, it will be automatically uploaded to S3 buckets. So after we upload the data, we scan this data, we extract some metadata from it, and store it in a database as an index, as a data catalog. Why do we do this? We do this because we wanted to keep an overview about the available data on AWS. We wanted to know like how much data we have from which vehicles and so on. And this is really important because later when we want to search for a specific type of data from a specific vehicles for our engineers, we needed to know where this data resides. And I'm talking here about the raw data, first of all. So we do this by having this data catalog solution, which we built using serverless Amazon Aurora with auto-scaling. Now, after we have imported the data, we have indexed the data, the next is how to process the data. And the focus here is mainly on the extraction of usage profiles. Why do we do this? Because we wanted to know how our customers are using our vehicles. We wanted to understand how they use it in order to be able to build better vehicles for them. And also in order to compare those with the usage profiles of our testers in our test fleet. And when we talk about user profiles, we mean a set of features like the average speed, like the number of starts and stops every 100 kilometers, how often the doors are opened, and so on. But there is also features like the percentage of driving hours in the city compared to driving hours on a highway. How about the fuel consumption during a trip? How about the component load, and so on and so on. A long list of features. These are just a few examples of them. There are some basic features. There are some more sophisticated features that needs to be calculated. All these features together build what we call a usage profile. When data is uploaded, every time new data coming from a vehicle is uploaded, we have to calculate these features. We have to update this profile to keep it up to date. So this is what we do with this raw data. The thing is that this set of features is not fixed. It's dynamic. It depends always on the requirements. So there is always new requirements from our engineers depending on the project they have for getting some more insights, for getting some new features. So we needed to be able to add more and more features over the time. We wanted also to be able to process every new data or new data delivery and update the existing features. So this is the dynamic environment. This is also one of the important things that we had in mind when we built this solution. And that's why we have decided to use serverless solutions. We also decided to use components that are very flexible, like here, in this case, Lambda, AWS Lambda functions. I will give you a bit more details about it in a minute, the next slide. Now, having processed this raw data, having extracted all these usage profiles and all this set of features, we store them in a storage that we call a feature store. And here it has been important that this feature store is is so flexible so that we can extend it easily when we have new features. That's why we decided to use an NoSQL storage system. It has also to support textual information because we have this kind of unstructured data. And here the decision was to use Elasticsearch. And we use managed Amazon Elasticsearch service in order to reduce the complexity of setting up this and scaling it up and configuring it. Now, closer look into the processing pipeline. In order to be able to have this flexibility in the design, we decided to build this as a pipeline that consists of a lot of smaller steps. So there is steps for pre-processing the raw data. There are steps for extracting the features, for example, extracting basic features, simple features, but then some advanced features that might need some of the pre-calculated features. But then we have also the steps for ingesting the data into the feature store and so on. So there are many, many steps. We divided this pipeline into such smaller steps. Each one of them triggers the next step. So in order to have this processing automated, we build this pipeline so that once the data is uploaded, this will trigger the first step, which will do the pre-processing. Once this is done, it would then trigger the next step, which will, for example, extract the features. And when this is done, it will automatically trigger the next step, which will store the data in the feature store. So this is a fully automatic process. And the way we implemented this is by following this design pattern. Bucket, the data is in a bucket. When the data is created, like after the upload, this would trigger an event that will be sent to SQS queue. And the Lambda function would fetch those events from the queue, process them, create results, store them in a bucket. This creation of the results in the bucket will trigger the next queue and will also trigger the next Lambda, and so on. So this is the design pattern that we have. And whenever we needed to add an additional step, we have to add these three components. And this is very interesting because it allows us to make our systems very flexible, but also very scalable. We decided to use this combination of SQS and AWS Lambda because we wanted also to be able to monitor the whole pipeline. By doing so, we have more visibility of what's going on. We can see at every point of time how many events are in which queue, what is the load on a specific Lambda in the pipeline. We can decide to increase the concurrency level when needed or reduce it when needed, and so on. So this is a very, very nice feature of this design. Now, after having processed the data, having created the features and stored them in the feature store, the last part is about how we get this data now downloaded, how we can use it on our premises systems, in our premises environment. And to do so, we had a very simple solution. We simply use an AWS Lambda as a proxy and an API gateway as an interface to this solution on AWS. So whenever our engineers within the Volkswagen network need access to these features, they can call this API, they can get the data from the feature store. This is also possible to automate because easily automate it, because then you could also just query this feature store from time to time to get all the updates about the process data. And it works very nice. We can get the data downloaded. It's then joined with our other data sources within the data warehouse. Our engineers are able now to use any self-service BI tools for analyzing the data, visualizing it, and making useful usage out of it. So, in summary, what we have shown you here is how we build this very scalable solution to process terabytes of data on AWS, to extract some useful insights out of the data, to have this understanding of the usage of the vehicles by customers, to be able to compare it with our testing procedures and with our test fleet. So starting from the vehicle and the data, creating the insights, we can then learn from it and build better services and better products for our customers, which is a win-win situation. For us, we can now better understand the needs of our customers. It's also a win situation for our customers because now they can get the vehicle and the service they need. Thank you very much for your attention.